Hi. In this session, we're going to be going through the concept of covariance, which is really, really critical for understanding how things work in investments within the context of a portfolio. So let's take a look at our notes on page 3, which I'm going to bring up here. Okay, so hopefully you can see this on your screen now. And first of all, let's take a look at this formula for covariance. It says that the covariance between A and B, which is any two generic assets, is going to be found by taking the return for A minus its expected return, multiplied by the return for B minus its expected return. In other words, we're saying how far is A from its expected return, multiplying that by how far is B from its expected return, and then multiplying that by the probability of getting that particular return for A and that particular return for B. I want you to note, first of all here, if the return, if A is higher than it is on average, which is the expected return. So if the return for A is higher than its expected return, this term will be positive. If the return for A is lower than its expected return, this term will be negative. So what's important here in covariances is we're noticing, we're going to be observing, is A above or below its expected return, and by how much? And is B above it or below its expected return, and by how much? And when we sum all this together, what we find out is, on average, do A and B tend to move together, or do they tend to move opposite each other? In other words, A and B are going like this, okay? If they're going like this, they're moving up and down together. If they go like this, they're moving up and down opposite each other. That's what covariance measures. Variance was looking at one asset. Does it move up and down a little bit, or does it move up and down a lot? Covariance looks at two assets. Are the two assets moving up and down together? That's a positive covariance. Or are they moving up and down opposite each other? That's a negative covariance. And because these assets don't always move exactly together or exactly opposite each other, the number is going to tell us, do they tend to move up and down together or tend to move up and down opposite each other, and how much? So let's take a look at the example here. So here's asset A and asset B. Now I made this fairly simple here, where we said there's 5 different states of the economy, if you will, okay? And they all have equal probabilities. When we have probabilities, probabilities always have to add up to 1. Something in the world has to happen. So whenever we have probabilities, they have to add up to 1. In this particular case, each of these probabilities are equally likely, but it doesn't have to be that way. They could all be different. So we can think of this as being the first state of the economy is a normal economy, and the probability of having a normal economy is 0.2. The second one could be if we have inflation, and that probability is 0.2. The next one could be if we have recession. Next one could be a booming economy, and the next one could be, a below average economy. So they can be whatever you think, but there are 5 different things that can happen. Each one has a 0.2 probability of it happening. So if this first thing happens, okay, right here, if that first thing happens, then A is going to be up 11% and B is going to be down by 3%. If this second state of the economy happens, A will again be up by 11%, B will be up by 15%. If this third state of the economy happens, A is going to be up by 25%, B is going to be up by 2%. And you can see it through there. So in order to find the covariance between A and B, we've got to first find their expected returns, okay? Because what we want to know is, does A tend to move up and down, does A tend to move up above its expected return and below its expected return when B is moving above and below its expected return, or opposite of B? So the expected return for A, we learned how to do this in our last video, is going to be 0.2 times 11%, plus 0.2 times 11%, plus 0.2 times 25%, plus 0.2 times 5%, plus 0.2 times negative 2%. So it's going to be the probabilities times the returns for the expected return for A. And that ends up equaling 10%, which as a decimal is 0.1. B has an expected return of 8%. Okay, and you can see that also. 0.2 times -3% plus 0.2 times 15%, etc. So A and B have different expected returns, and that's fine. Now, to find their covariance, we're going to take the probability of this first state happening, which is 0.2, and if it happens, we want to say how far is A from its expected return. Well, if that happens, A has a return of 11%. Its expected return is 10%. So, and it's best to keep these as decimals. So 0.11 or 11% minus 0.10 or 10%, that's how far A is from its expected return. In that same situation, how far is B from its expected return? That's going to be -3, the return for B in that first state, minus its expected return of 8%. So that's right here. Now notice that A is above its expected return. A has a return of 11% with an expected return of 10%. B is below its expected return. It has a return of -3% with an expected return of 8%. So A is going up above its expected return while B is going below its expected return. In other words, they're moving in opposite directions. Well, you can see this is going to give us a negative term for the covariance. 0.11 minus 0.10 is going to be a positive number. Negative 0.3 minus 0.08 is going to be a negative number. When you multiply a positive number by a negative number, you get a negative. So this first term is going to be a negative number. And of course, it's weighted by the probability that this event will happen, which is 0.2. Now, in the second state, A has a return of 11%, again, above its expected return of 10%. Okay, so you're going to see that 11% minus 10% is going to give us a positive number. B has a return of 15% compared to its expected return of 8%. So B is also above its expected return. So A is above its expected return, gives us a positive number there. B is going to be above its expected return, gives us a positive number there. A positive times a positive is a positive. So this second term will be a positive. So in this particular state, the second state where there's a 0.2 probability that it will occur, A and A tend to move in the same direction. They both move above their expected returns. So that gives it a positive term. So far, we've got in one state, they're moving in opposite directions of each other. The other state, they're moving in the same direction. And what we can see is every time they're moving in the same direction, be it up or be it down, this will be a positive term in determining the covariance. When they're moving in opposite states of each other, it will be a negative term in terms of determining the covariance. So when we get all of this put together, the question is, on average, do A and B tend to move up and down together, or do they tend to move up and down opposite each other? And what we end up with, if you do the math on this, is negative 0.0026, which is a negative term, a negative number. So it tells us on average, A and B tend to move in the opposite direction of each other. They don't do it all the time, as we saw, but that is the tendency, is to move in opposite directions of each other. Now, just like what we saw with variance, that it's generally we will use decimals to measure covariance, okay, to record covariance, to talk about it. It's not wrong to say it is negative 0.26%, but it's just generally typically not done that way. Now, one of the things I want you to notice about the covariance formula that we looked at up here, okay, is that it is the same thing as the variance formula when we are comparing not A with B, but A with A. So this was comparing the covariance of A with B, right? Suppose we want to look at the covariance of A with itself, or any asset with itself. Well, the covariance of any asset with itself is its variance. See, when we had two different assets here, A and B, we took a look at the return on A minus its expected return times the return on B minus its expected return. Now, if it's A with A, then what we're looking at is the return on A minus its expected return multiplied by the return on A times its minus its expected return. So the return on A minus its expected return times the return on A minus its expected return is the return on A minus its expected return squared. And that is exactly what the variance of A is. So this is going to be really helpful to us later on. Variance and covariance, notice their names are similar, are the exact same thing. It's just that variance is when we're doing a covariance of something with itself. In other words, the covariance of A with itself is its variance. If we're looking at two different assets, like A with B, then we refer to that as covariance, the covariance between A and B. So covariance is telling us, because we have two assets, do they tend to move up and down together, or do they tend to move up and down opposite each other? Now, the problem with this covariance, okay, thing is that this number, negative 0.0026, while it tells us they tend to move up and down opposite each other, it doesn't tell us by how much they tend to move up and down opposite each other. Is this like a lot? They tend to move way opposite each other, or they tend to mostly move together, but a little bit opposite each other, or it's mostly random with a little bit opposite each other. This doesn't give us any kind of a scale for it. Something that will help us give it a scale is the correlation between A and B. Correlation and covariance measure the exact same thing. Just like variance and standard deviation measure the same thing, just like hours and minutes measure the same thing, just like feet and yards measure the same thing. Okay, but they use different units. Now, if we want to move, and we talked about this before, from feet to yards, you divide by 3. Then if you want to move back from yards to feet, you multiply by 3. So you can talk about distance in either feet or yards. With covariance and correlation, if you want to move from covariance to correlation, what you do is you're going to be dividing by the standard deviation of A times the standard deviation of B. So if we go to this next page, the correlation, and we can call it correlation coefficient or just correlation, either one, which is given by this Greek letter rho. It looks like a script P, right? And it's a Greek letter, rho, R-H-O. And so the correlation between A and B is going to be the covariance between A and B divided by standard deviation of A times the standard deviation of B. Then if we want to go back from correlation to covariance, you take the correlation between A and B, multiply by the standard deviation of A times the standard deviation of B, and that will give you the covariance between A and B. So why do we bother learning both correlation and covariance? Well, because there's different times where it's helpful to use each of them. Just like sometimes it's helpful to talk about time in minutes. Sometimes it's helpful to talk about time in hours. The thing about correlation, though, is that it's going to be very intuitive for us because it is bounded between +1 and -1. The correlation between two assets will never be higher than +1. It'll never be lower than -1. See, if two assets move exactly, perfectly together all the time, the correlation will be +1. If they move exactly, perfectly opposite each other all the time, their correlation will be -1. Now, you're never going to find two naturally occurring assets that either move perfectly up and down together all the time or that move perfectly opposite each other all the time. However, we can create derivative assets that do that. Derivative asset would be, this is not a course in derivatives, okay, but it would be things like options contracts, futures contracts, swaps, insurance contracts are derivatives. It is where one asset's value is derived based upon the other asset's value. I'll give you an example. I've got a house, okay? Let's suppose my house is worth $100,000. Now, if the house does not burn down, it's worth $100,000, right? And let's suppose I've got a homeowner's insurance policy that insures against fire. If the house doesn't burn down, the homeowner's insurance policy is worth 0. But if the house burns down and the house is worth 0, Now, all of a sudden, my homeowner's insurance policy is worth $100,000. So either the house is worth zero and the homeowner's policy is worth 100,000, or the house is worth 100,000 and the homeowner's policy is worth zero. They move exactly in opposite directions. They have a correlation of -1. We're going to see that that's very important. Assets, pairs of assets that have a correlation of -1 can be used to eliminate risk. You can create a risk-free portfolio by combining two assets that are perfectly negatively correlated. We're going to talk about more on that later, but right now, just want you to understand this concept, okay? Covariance and correlation measure the exact same thing. Covariance can be any number, really, okay? Correlation, the highest it can be is +1, the lowest it can be is -1. Now, what's in the middle, obviously, is zero, and zero just tends to mean typically that it's totally random movements between the two. They don't tend to move up and down together, nor do they tend to move up and down opposite each other. But something that's very significant is if one of the assets is risk-free. Now remember, the risk-free asset, its definition is that it has a standard deviation of 0. So the risk-free asset doesn't move. If we've got a risk-free asset not moving and we combine that with a risky asset, well, look, those two assets aren't moving up and down together because the risk-free asset doesn't move. They're not moving up and down opposite each other because the risk-free asset doesn't move. So the correlation between the risk-free asset and any other asset has got to be 0. It's not positive, it's not negative. Their correlation is 0. If the correlation is 0, the covariance also has to be 0. So positive covariance, two assets tend to move up and down together. Negative covariance, they tend to move up and down opposite each other. 0 covariance, either it's totally random or more likely one of the assets is risk-free and it's not moving at all. And if we know the covariance, we can find the correlation. If we know the correlation, we can find the covariance. They both measure the same thing, but correlation, the highest it can be is +1 when the two assets are moving exactly together. The lowest it can be is -1 when those two assets are moving perfectly opposite each other. That's it for correlation and covariance. In our next time together, we'll be talking about a really important concept called a portfolio.